project idea about the betting thing last time, right? So is there anything you can show us, Adrian?
Right?
Adrian,
Yes, I
yeah,
think I can start with the presentation. Here we go.
here we go.
So let me share my screen.
Yes,
And
please.
can everybody see my screen?
It's building coming up. Yeah, I can see.
Okay. So I think I will explain a little bit how it works, the validator or
Mhm.
the system, and then I will do the happy path and some other paths in order to to see that it works. And well, the first thing that I want to show you is the the validator itself, and
Okay.
this is validator. So we have this validator. Mm, the flow of this betting system is the first thing that you have to do is to uh, put the money in a minting in this minting bet, so you can get a token, and you will put that token in other spending validator, and after that the person who is the owner of that system will be able to retrieve all the funds, and also to split the funds in the way that is uh, mm, is coded here. So uh, this mm, this file will work as a minting validator, and also will work as a spending validator. That's a little tricky uh, thing, because we have to put okay, so we have to make sure that this can work in with both purposes, the minting and the spending.
Did you actually manage to get that to work? Because I know, I think at the Cardano Summit in Dubai last year, I had a discussion with somebody who said he tried that and he never got it to work. So you managed to use the same script both for validator and minting? Cool.
Yes,
Interesting.
yes. With this validator, uh, we have to apply another parameters, and put that parameter into the list, because what will it will uh, we will get from this script, in the case of the script spending script, the minting validator, I mean, we will get the a function that is that only left one parameter to be useful. So we have to pass this parameter, and that parameter will enable us to use this script as both mint and spend validator. I don't know if I explained that uh, well, or
I'm actually not really sure. So the point is a minting validator when it takes a redeemer and the script context, right? And the spending validator takes three, I mean, a datum redeemer and the script context.
right.
So how does it work that the same script can have two or three parameters or arguments?
It's just because we okay, let me share the other part of this. Okay, in this one we have these two parameters, two functions. In this function we are applying uh, all the all the all the parameters, and this will work as a spending validator, because we are not applying the last one. In this other one, we will get another minting policy, because we are passing void at the end of the parameters. And with this, instead of getting a function uh, that is what we will be getting when we were trying to get this mm, this policy. Uh, we are applying that function, and that will uh, enables us to get the minting policy, just applying this one at the end of the array.
Okay.
So that's for it. And the second part, okay. So we have to validate the minting, and we have to validate the spending. The first part, okay, we will focus in the minting, and we will expect that we get a single a single uh, element in this list, that is of the assets, the tokens, I mean, from the this is from the mm, policy ID. What's context? Okay, this is from the that we are generating, the tokens that we are generating. And after that, we will get the output that is the same. Okay, we are filtering that we are seeing that this is from a script credential. And after that, we need to check the datum. The first thing that we have to check is that uh, is an inline datum. And after that, we have to check two things. The first thing is that the you only will be able to bet before the deadline. So the upper bound will be less than the deadline. And also that your bet is the same as the the actual funds that you put in that transaction. And that's all. And also we will check that is one, and the asset name is the same as the token name. And that's all for this. Uh, any question so far?
So just to recap on a high level. So when you place a bet, you in one transaction mint this token with this
Right.
minting policy, and you have an output to the bet address smart contract with your actual that contains your actual money, the bet,
right? With the
and the
bet and the
and
token,
and the token that you just minted.
right?
And by using this, you can guarantee that the datum, I mean, that the output is correct. I mean, that it's, I mean, you can check that it's placed before the deadline and that the datum doesn't lie about the amount that you bet.
Right. And that is before the deadline also.
Yes, yes.
One question. So you are checking that the output goes to a script, but how do
Uh,
you know that is the correct script?
yes, I was doing that, but we, mm, I think I had some problems with that because uh, I didn't. I had to pass the actual address in order to check that is correct. But I am just letting that the validate the person who is doing the transaction can um decide whether it will like to send the money to the validator, that is the spender validator, or not.
Right, but I'm not sure if I understand correctly, but in that case, I will be able to mint and send the money to a smart contract that I control, and I can take the money out, and I still got it to mint.
Mm,
Uh, yeah, so maybe, yeah, I think I'm not sure if you do the check other in on another part, like in a different. No, I think this
okay,
is the other is NFT and Oracle. So yeah, I think either by parameterizing or some other way, then needs you need to check that you are
yes,
sending the actual script, not any script.
okay, yes, I was doing that, but I had some struggle with that. But I think he's right here to where we have to do that.
Right.
I
Yes,
think.
it's right there. Exactly. Yeah, yeah, it's right there. Okay, cool. No, so it's just a to do. It's just a to do.
Right.
It doesn't break the architecture, so it's okay. Yeah,
Yes, thank you,
yeah,
Robert.
yeah. No, no problem, no problem. It just we can keep going, and then maybe we can actually fix it here, or after the fact, or after everyone presents their own thing, and maybe another day. I don't know. We can just
Okay,
add a huge to do for later.
sure. So let's do it with this one, with the validate spend. In this one, uh, we have to get the oracle. So we are going to make use of the reference inputs in order to get the actual oracle, and also we have to pass the oracle validator hash, that is the is to filter the minting hash, the policies of the input, and see if it is the actual um, oracle. And we are doing this. We are getting the oracle data from from the from the reference input, and we will get an option of the winner. It will depend on the mm, when do we query the transaction. For example, if we are querying the transaction before the deadline, we're going to get a non uh, a non-winner or optional equals to none, and otherwise we will get the winner. Mm, so we are expecting that we will have only one uh, input. We're filtering that input from using the Oracle val, that is the script hash, and after that we're checking that the datum is the correct, the inline datum, and also that it is part of the option winner type. And that's all for this. The other part is the filtering. Okay. So, uh, any
Excuse me,
question?
the winner, sorry, the winner type. What's the shape of the winner type?
The winner type is okay. We have this in a. We just have these two constructors, the fighter one and the fighter two, and that's all.
Okay. So then, as while the fight is going on, there is
No winner,
no winner. So this will fail, and the transaction will fail until the fight is over.
right?
Okay.
So we have to update the Oracle in order to get the funds after the the uh, the deadline.
Okay.
So okay, and we have here.
You only have one deadline, right? Or are there two?
No, only one deadline. The
Right.
the deadline is part of
Meeting.
the the match params of the meeting.
Right. So the deadline is before the fight starts, and then the oracle will only be updated after the fight ends. But during the fight, you can't place bets anymore. Right.
Mm, no, this is the deadline. The purpose of the deadline is to uh, it means that the the fight begins. So
Yes.
after that, you will not be able to put any money
Right.
into the
But
validator.
you can only collect your winnings after the fight when the oracle
Right,
has decided. Right. Okay.
that's true. And after that, we are getting all the inputs from the policies. In these inputs, we are also getting the minting hash that we will get from the redeemer. We have to pass the redeemer a minting hash, and this minting hash will be the we will compare this minting hash with the policies of the transaction inputs, and this will check that all the NFTs, the tokens, I mean, of the input are the same of the minting hash. That's all, and we have to we given that input, we will split that um that input, and we will check that the is after deadline the spending, and we were going to see this. We're going to see this. Um, okay, we have the expected outputs and the actual outputs. The actual outputs we're going to format this. This will we will concatenate the book key hash of the output with the number of the string, the number of the levelize of the money. So that will be something like a string that uh, will be like a transaction to identify an input, and we will compare that, mm, right here in when we are getting out the expected outputs also, and we are going to check that the expected outputs are the same than the actual outputs. So we have to check that the actual outputs are in the list of the n- I mean we will the concat output are in the same list of the actual outputs that are this like list of strings that represent every string represents an output, and we will follow with this, and we will mm, uh, check that every single output is correct. So
So
that
just for me to understand, so when people bet, I mean, for each bet there is one transaction. That means this NFT and puts the bet at the UTXO at that address. But then when you collect, you are supposed to use all those UTXOs as input.
right. So I did something just to make an incentive for the person to to collect all the UTXs, and that's that we have a fee, and the fee now is just 10%. So every time you will retrieve all the funds, you will get the 10% of the total bet. So it's an incentive to get all the funds.
I see. So there's only one such transaction. So ideally it would collect all the funds and then distribute all the winnings to the people.
Right.
Okay,
Right.
and you incentivize people to take really all the inputs by giving them a fee,
Fee. Right.
10%. Okay.
The 10%. And displayed correctly. I think that's it from the utils and the minting bet. We are splitting correctly. We're checking that we are splitting correctly, and we're checking this after line that we are getting all the funds, retrieving all the funds from the spending validator. And that's it for this. Mm, so I think we can check the that it works, or the off-chain code a little bit, uh, just to know how it works, the life cycle. So the life cycle is that's the first thing that you have to do in order to to begin with this is that you have to or set some parameters, and you have to put those parameters in this JSON. This JSON will contain all the information that we need, uh, the fighter, the name of the fighter, the fighter one, the fighter two, the POSIX time, that is the deadline of the match, and the owner of this this system. And after that, we have to run the oracle, no, we have to deploy the oracle firstly, because this will be a dependency of the of the of the other validator, and we have to pass the match path that is the same that than the match JSON. And after that, we have to create. mm, uh, we can bet. After that, we can bet. For example, we can bet, but we have to. Okay, I forgot to mention that after is deployed the Oracle, we will get another JSON, that is this Oracle JSON, that will contain some information of the Oracle, and that we can use in the betting and the splitting transactions. And the Oracle, okay, the betting. After that, we can bet, and we have to pass the match path, the Oracle path, the user path, that is the who makes the transaction, and what is the bet, and uh, what is the winner of the bet. And after that, we have to wait on that the deadline, that the time is after the deadline. So we have to check that, and we can update the Oracle. When we are updating the Oracle, we have to pass the match path, the Oracle path, and where is the winner of the match. And after that, we can split the funds. We can split the funds passing the match path, the Oracle params, and also who is gonna get the who is gonna retrieve the funds and split the funds, that will have an incentive to do that, to do it correctly, and with a fee, with an incentive. And so I don't know if anyone has any has a question.
What happens if fighter A wins, but all the bets are for fighter B? Do the people then get their money back?
This is the idea, but with this implementation, I haven't put that logic into the smart contract, but that's the idea. So in this case, in this with the current code, all the funds will be sent to the person that is splitting the funds. But I think that the idea will be that put that logic into the validator, to check that if the there's no winner, so you can retrieve your funds and you can get your funds. Okay.
Right. And did I understand that correctly with the incentive? So the person that creates the transaction that collects, I mean, that does the distribution, gets 10% or whatever of all bets.
Right.
But I'm not sure that that will always be the right incentive. I mean, just imagine, I don't know, so the fight is between A and B, and 2 people bet on A and 20 bet on B or something. So then if the person, I mean, one of the two that bet on A if he does the collection, I think he has an incentive to not include the other bet on A. I mean, he loses the 10% from that bet. I mean, let's say, whatever, to make it concrete. So Alice and Bob both bet on A, like, say, 1,000 ADA each. And then there are 10 people that bet on B, so 10,000 there. If now Bob does the distribution and doesn't include Alice, then he
Okay.
gets the 10,000 of the people that bet wrong. But if he does include Alice, he gets her 10%, which is 100 extra, but he loses 5,000 because she gets half of the bets of the B people.
Okay.
So
Uh,
one quick solution, which I mean, we already are depending on the Oracle to tell us what's the who won. So you could add the amount of bets, and you can enforce that the amount of inputs, UTXO inputs, have to match the amount of bets.
right.
But then you have a like scaling problem, right? Because
Yeah,
somehow
yeah. I mean,
right.
you have scaling problems, I think, already. So
Sure,
Right.
sure.
yeah, that will be a solution that fits into this architecture.
Another solution could be that we can restrict the person that is retrieving all the funds that cannot be part of the betting.
Yeah, but that's
Also,
hard to enforce because somebody that is actually part of the betting could just create a new wallet address, and so it's difficult
okay,
on
right.
Cardano because I mean it's difficult to
Enforce that.
know who, I mean whose identity it really is. It's easy to create a new key pair
Right.
and then nobody knows it's you.
Okay. Just that's another good question for that. But I don't know how to solve that already.
Right. I mean, of course, I mean, seeing as you, I mean, it only works if this distribution transaction basically collects all the bets, which means there's some limit. I mean, depends on how complex the smart contract is. I mean, if you don't have smart contracts, I think you can have a transaction with roughly 200 inputs, something like that. So it's something like that. It's probably much lower because of the smart contract. But even if it was 200, that means probably your system would only work for up to 200 people. And for that, probably Robertino is right. I mean, you could have some mechanism where each time you place a bet, you actually have to increment some sort of counter so that every bet is actually recorded. And then it would be easy to insist that when you collect, everything is, I mean, you don't miss an input, I suppose.
I think the idea of Robertino was that we only put the amount of the of the transactions, right, or something like that.
Yeah,
he
no,
said,
the amount of bets. I mean, you could incrementally, I mean, because the Oracle only provides the value after everyone could make bets, you could ask the Oracle, like whatever system the Oracle is, to not only provide the value of the end of the match, but also provide a trusted number of bets in the
Right.
same so.
oh yeah, that's true.
Because
So
okay, go ahead.
no, I mean, I agree probably. I mean, you have to trust the Oracle anyway, so you can also trust it probably that it tells you the correct number of bets. No, I was saying you could also, instead of using the Oracle for that, each time in your minting policy, you could basically ensure that some sort of counter is incremented each time.
Right. That's a good idea.
Right. But
So,
anyway, so, okay, yeah, so maybe we can proceed.
yes,
You're
I
off
think.
track.
So that's the part of the code. So I think we can start doing some some tests.
Yes, okay.
So the first thing that we have to do is to build the icon, but I think we didn't we didn't update the code. But anyway, the second thing we have to create the data. I made another script to create the data to put the time that is something like 3 minutes after the creation of the data. So the running of the script. So let's do it. This is the script. Data just creates the data, the match, uh, the match data, and we will add the something like 3 minutes, and that's all. So after that, we have to deploy the Oracle. The Oracle will be this one. Okay, I mean, I think that we have the data. The we can delete this Oracle, so we can deploy the Oracle, and we will get that Oracle JSON again, and with a different uh, information of the current Oracle. And after that, we have we can start betting. So, for example, if we have Daniel, that Daniel puts, I don't know, maybe Tuada, and we will bet to the first one. In this one, we have to pass the match JSON, the Oracle JSON, the assets, mm, the asset hash, the okay, the okay. Any question?
Oh, all good.
Okay, we have to put this. This I think is the private key, and we will convert this to uh, uh, the address, and that's all. We have to put the number of ADA and which one we want to bet. That's all. Okay, I think we have an error. Okay, we're splitting right now, but I want to bet. So Cesar will bet to Ada in the fighter one. Okay, I had an error. Script.
Is there an error that you didn't uh, add an explanation? Because I saw that when you parse the datum, you actually trace something.
Oh, in this one? That's because I was splitting the funds instead of betting the.
No, in the contracts, because you got an error without an explanation. So that's like somewhere there is an expect or something like that that is not.
Oh, right here or where juice?
On the contract. Oh, I mean, you could try it again if you want, but I'm not sure if you will work out.
Okay, let me do it from the beginning. But we have to create the data. we have to deploy the oracle. And then we can.
Oh, okay. I'm not sure if you did that earlier.
I think that this I didn't make the
The Oracle. Yeah.
calc, right? And we can do another bet here for Daniel of 3, maybe for 3 for the other one. And that's it. We have to wait. Okay, we can wait that the match POSIX time has passed in order to try to do another transaction and see that we are not allowed to do that. So
Yeah. Do you mind navigating with Cardano Explorer to the
okay,
validator's address to see the two UTXOs?
okay, this is the. Am I sharing the my
Mm,
screen correctly or?
I only see VS Code.
Okay. Yes, I think I have to change this one. Okay, we have the two transactions that are 5 ADAs. And the first one, oh, okay, we have different directions from the transactions, and that's it.
Nice.
And after that, okay, we have to check what is the match POSIX time in order to see that we cannot bet after the deadline. Okay, I think I will not be able to do another transaction right now. So let's try. Maybe we can see the POSIX times here. Oh, okay. We are not allowed to do another transaction because the deadline is before the transaction. So that's the something that the validator
Nice.
doesn't allow us. Okay. So after that, we have to deploy the oracle to update the oracle in order mm, to have something in the datum and get and we have to do it with the same eh, with the same the person that is the owner of the oracle. Okay, update oracle, and we're getting the information from here, and here we're getting the owner and the oracle JSON, and we want to change the datum of the oracle of the UTXO. And okay, that's it. And the transaction has been submitted. Maybe we can check that. Okay, it's not submitted, but we can check the Oracle address in order to see the first transaction. That is the deployment of the transaction. This is the one, and we can see the transaction and the UTXOs from this, and we will get the datum, and the datum is a constructor of the first one of the first one constructor of the datum. So this means that we don't have uh, any winner. So this is the none of the option structure,
Mm-hmm.
and maybe we can see the other one structure. Okay, I think we have updated successfully the oracle, and we can see that the datum. Okay, this is the first one. I think. It's this one, and this is the other one. The other structure, that is the first constructor with the first constructor of the winner structure. So that means that the fighter won, and we can see it in this means. We can see it right here that this is the first constructor of the winner. So that represents this one, and that's it. So after that, we can retrieve all the funds. And okay, we have this script that will get a match JSON, an Oracle JSON, and the private key from the person who will retrieve all the funds, and that will calculate all the outputs and get the information, get the funds, make the transaction in order to get the funds. So we're doing this right here with this for loop. We are making the transaction, and we are adding new winners. And that's it. Because we just had 5 as the bet, we get only 90% of the bet, and the other part will be sent to the person who retrieved the funds to unlock the funds, and that's it.
Awesome. Great project. Great first project, actually.
Thank you very much, Robertino.
That's really good. I think yeah, I mean, I don't have any questions. Do you? Because maybe you want to figure out, like, I don't know, something of how to scale it, or how to work differently, or maybe you want to see how you can move this into an actual product, or I don't know. Do you have any questions or anything else you want to discuss?
No, I think we discussed the things that were more critical for this project, because, for example, the part of the how to make sure that every single UTXO will be in the transaction, in the completed,
Consume as an input, yeah.
right? And how to escalate that. I think okay, that's another good thing to discuss. For example, how to escalate this solution, or there's another solution that I can implement in order to escalate this in a better way. For example, I don't know, maybe I don't know what is what are the things that we have to take into account in order to escalate this project. For example, if we can reduce the complexity of the code, or should we maybe reduce the amount of code, or reduce the amount of variables, or something like that? Or what is needed to in order to escalate this project?
Right. So I think the first, like the most important, and maybe if you solve that, it's solved, the escalation, depending of how you do it. But you have to assume, or like you have to assume that you're consuming all inputs. And so that's, you can enforce that you're consuming all inputs by doing like what we just said about the adding the amount of bets to the oracle, but that doesn't scale, because as soon as you have like 300 bets, your validator won't fit all, like you cannot fit all bets in a single transaction, so it will be impossible to actually like cash out. So you have to find a way to avoid the need of consuming all inputs, and it could be done in different ways. But I think I like the idea of each UTXO being like a standalone atomic expression, or everything you need to actually like cash out. So if in a single UTXO you have all the information that you need to make the decision, and you don't care about other UTXOs, then you solve the issue, because then you can have either 1,000 UTXOs or 10,000 UTXOs, and you don't care. You just take a subset, a small subset, and just consume that small subset, and then in another transaction you consume another subset, because everything you need to enforce the logic is already sitting in the UTXO.
Okay. Instead of making multiple UTXOs and but for example, in that UTXO you will have the all the information. For example, the amount of tokens, the datum of the winner, or something like that. All Every single person who bet in a single
Right.
validator or something like that.
Yeah, I mean, you cannot have that because you have to update all of them every time someone creates a new
Right.
bet. So, but I mean, there's no need for that. So, for example, in the current system, you can consume not like a subset of the inputs, and the validator will still pass, right? So
Right.
it's not that because the validator doesn't know that that's not all of the inputs.
Right.
So now all we need to make sure is to provide like more constraints on top of the ones that we have that make sure that even if you consume a subset, you have nothing to gain from it.
Okay. Okay.
So let me think. So I think Lars already like explained one exploit that we could do like to the vulnerability. How can we stop that? So we have incentives to consume, like to try to. We have incentives to consume the UTXOs that didn't win, because those are the ones that we're going to like take the money, right?
Right.
The
I
budget.
just had an idea. Sorry, I just had a novel idea. I think what one could do to make sure that there is an incentive to always collect all of them, even if the Oracle doesn't know how many there are. I mean, that makes it more complicated, but maybe that would work. You could do that. The person that collects or distributes the winnings, that that all the I don't know, maybe not. Sorry, I think. No, I was thinking that he has to put down some collateral, like high, and then if there is a bet that he didn't collect, then somebody can basically use that bet as proof that he didn't collect all of them and grab the collateral. So that might work. You know what I mean?
Yes, I'm thinking that right. I think it will work. It will be but you will be like the badger will have to put less than what it gains on the transaction, else no one wants to be the first. So the
Except
collateral,
if,
yeah. Sorry.
I mean, except if you can be sure that. I mean, if you collect all of them, there's not really a risk. I mean, you will not lose your collateral. So, I mean, that might actually work. I mean, somehow the idea would be that if there's a bet left after this distribution, there's some way for, I mean, using that bet to grab some like very high reward. Yeah, well, sorry, it was just an idea.
What if we add a second deadline, like I don't know, 1 month after the fact, or 15 days, something like with enough time that everybody has time to create a transaction. So sort of like a vesting script that you take, instead of 10%, you take 8 and send 2% to that script. And then that script like sort of accumulates the let me think, because I'm not 100%. I didn't flash out entirely in my mind. So the thing is, we can log that that as collateral, not collateral from the badger, but as a subset, like as percentage of the winnings are locked, and you can only unlock them. I mean, and everyone can. Let me think. Yeah, so I'm trying to not spoil the winnings of the badger, so everyone wants to make the transaction as soon as possible.
Right.
Yeah, so I was thinking that maybe there's like a deadline in which before that deadline, every output has to be consumed. And after, like we can check that. So there's after the fact, after once that deadline passes, the badger that actually like consume a subset can get his share, like the final 2% that was locked, because no one can prove that there were still more inputs to be consumed, something like that.
Mm-hmm.
I'm not sure if there's an easier solution.
Not sure. And then of course there's this idea that, I mean, with this linked list, and that of course is a bit more complicated, but where basically all the bets form a linked list. So when you start the system, I mean, somehow there's a beginning, like a beginning marker and an end marker, like two UTXOs. So the begin is part of the parameter. So that's like publicly known. And then when you place a new bet, you must somehow put your bet somewhere into this linked list. So the point of this is that it's still, I mean, the naive solution would be that not every bet is placed in its own UTXO, but there's only one UTXO, one global UTXO where everybody places the bet. I mean, then everything would be simple, right? Because then there's no problem. I mean, then there's only one input that contains everything. But the problem with that, of course, is that, I mean, it doesn't scale because everybody competes for this one UTXO. And Adrian's idea is that, I mean, it's completely like independent. People can place their bets completely independently, which is nice, of course, because then it does scale. But the problem then is that what we are discussing now, that it's difficult to somehow ensure that in the end everything is collected when you distribute. So this linked list idea is somewhere in the middle. So you basically, people, when they place a bet, they must insert it somewhere in this linked list. So, and the point is, you only have to like modify the one before and maybe after, or maybe only the one before in the list. So you have to like change the pointer that it's, I mean, include yourself into this linked list. So you change the pointer of the one before where you insert yourself to point to you, and then you point to the one that one pointed before, and the validator could check that. So basically in the end, all the bets form this linked list, and then you would have a phase, whatever, 15, I mean, some hours or days, where people get incentivized for collapsing that list. So by basically taking two links in this list and combining it to one, and they get a small incentive for doing that. And then the goal is that in the end, everything is collapsed to one, and then you can distribute. So that has the advantage that it's, I mean, it's sort of the best of both worlds, but of course it's a bit complicated to implement. But I mean, that might work, something like that. Does it make sense?
Yes, I think
Sorry,
it makes sense. It's a pretty good solution, I think.
Antonio to say something, I think. Sorry, Adrian, you wanted to say something?
No, okay, go ahead.
Oh yeah, well, I just wanted to say that I came to this idea of having like a UTXO with some sort of state, and then having other UTXO that will contain the bets. Uh, well, it is like a mixture of both solutions. Mm, Probably when you are betting, you are going to update the state UTXO. I don't know if that will work.
Right, but then everyone is there's contention for this one stake UTXO. So you still have this bottleneck that all the people that want to place a bet have to modify the same UTXO.
Yeah.
And then in principle, you could just as well just use that one.
Yeah, probably we can have like, I don't know, multiple UTXO states, because well, it will also solve the problem of the escalation. Maybe we can have like 5 or I don't know 10.
Yes, I think that is an option. I mean, it's still not ideal, but at least, yeah, you can scale that. I mean, if you have like a fixed number of those 5 or 10, as you say, that would also work, I think. But of course, then you can only scale to a specific. Yeah, okay. I think that's probably that would work actually.
Yeah, but you should have like or an off-chain endpoint that tells you which transactions in the mempool are already trying to use specific state tokens, state UTXOs, or you have to put like 100 to make sure that statistically you're going to pick one that no one's using.
Right. Actually, at Genius Yield, we're doing something like, or we used to do something. We're getting away from that now, but we used it for this rewards claiming system we had that idea. So people can claim rewards, and it's like global UTXO, so there's contention for them. But we have like 3 or so, and then the off-chain code randomly picks one. And of course, instead of 3, you could also have 10 or whatever. And then, I mean, you don't even have to keep track of mempools if you just pick one randomly. I mean, statistically, it's already quite likely that it works. Obviously, it depends on how much contention there actually is. But yeah, I think that would actually probably work if you have like 10 of these betting UTXOs, and then people pick one randomly of those and put their bet there or update the state there. That's probably going to work.
Yeah, it will work, but I'm thinking that I could also create 10 transactions and send all 10 with the different to make with all 10 possible states, so I can just make sure that my transaction is going to go through this block.
Yes. Although I'm not sure, I thought exactly the same ones, but I'm not sure how a node will behave if, I mean, you do these 10 transactions, of course, they all conflict each other. So only one of the 10 can possibly ever end up on the blockchain. Because I assume they all consume the same inputs, right, of your wallet. Yeah. And I'm not sure what a node does what a Cardano node does if it gets conflicting transactions. I think it might reject the next one.
Yeah, I'm not sure if you can pick the order of the transaction. I mean, that's a node thing, right? But the first one that takes is the one that goes, and then it starts to reject every other one. So it will be the first, but I'm not sure if you can pick which one is the first.
Yeah.
I think that's the node picks which one takes from the mempool, right?
Yeah, I actually, funny enough, I had exactly that discussion yesterday, I think, with a colleague. I think I may be mistaken, but I think I mean, the colleague said I was wrong, but I always thought that at Bitcoin, the mempools at Bitcoin can have conflicting transactions in their mempool. And then only when they build a block, they somehow pick a consistent set of transactions. But he claimed that's even wrong for Bitcoin and certainly wrong for Cardano. So I'm not sure how that actually works. Whether you can, yeah, I don't know. But I think nevertheless, I mean, that would work. I mean, if you have like 10 or so, I mean, of course, it wouldn't scale to millions of bets, but I think it would scale to hundreds because, I mean, if the deadline is, I mean, in your example, you had 3 minutes, but I think realistically it would be like at least a day or so or more. So then people have time. I mean, it spreads out over time. So they're not all competing for the same UTXO because they will try at different times. And then if you have several UTXOs, it's even better. So I think that would work for a couple of thousand maybe.
Yeah, I mean there will be a bunch of congestion at first because everyone is going to try to consume the same one because it's proportional to the bet. You want to like process the bigger bets, so everyone is going to try to process the bigger. But then you have this fun game theory thing that we explored in the hackathon. That maybe you can.
Yes.
Yes.
Of course, also another problem with all of this, I mean, apart from the fact, how do you guarantee that you collect all inputs? I mean, if you have like more than, I mean, you can also not have thousands of outputs in a transaction. So how do you distribute all the rewards in one? So maybe for that, it would be better if, I mean, you basically have a push model where somebody creates this distribution transaction and pushes all the rewards to people. Probably it would be better to have like a pull thing where people can collect their own rewards somewhere.
Right.
Maybe that's
And then,
that's because, for example, if we have a transaction with too many UTXOs, it will also be something that we cannot escalate or something like that.
exactly. It always depends, but I mean, like order of magnitude, maybe you can have like 100 inputs, 100 outputs or something, or 200, but certainly not thousands.
Okay.
Plus, there's also this issue with this min deposit. I mean, somehow the person that creates the transaction has to pay this 1.5 ADA min deposit for every output. Of course, maybe that can be taken from the inputs. I mean, that it gets subtracted from the rewards, but I mean, that's normally also a problem. If you want to distribute to many people at the same time, that's normally very expensive for the person doing the distribution. So it would be easier if, I mean, if people have to pick up their own rewards, then they have to pay for this. So that normally makes it easier. So if you had to weigh somehow in, I mean, if somehow the datum of whatever, of something can keep track of how many, I mean, you do this calculation, somehow this calculation needs to be done. But then if basically someone knows how many rewards you are owed, then so that people can just collect and then it keeps track how much has already been collected, something like that. And maybe you could even use these NFTs in some way. I mean, for example, if I understand correctly, now you're minting. I mean, you're minting one NFT, right, in your minting policy. I mean,
Right.
you could also do something like that. That people, I mean, that you mint more tokens. That one NFT goes into this UTXO in the betting UTXO, but you also let's say for every ADA or every Loveless you bet, you also you mint one token that the better gets. So that's like, I don't know what it's called because I'm not a gambling person, but I think in real life, if you place a bet, you get some piece of paper that basically proves that you did this bet. So maybe there would also be a way that you receive these tokens that basically prove that you placed a bet. I mean, the token basically says on which fighter you bet and how much. Or let's say for each Loveless you place, you get one of those tokens. And then somehow, you could do the calculation. I don't know if two people place 1,000 ADA on fighter A, so 2,000 is for A, and three place a bet, places 1,000 ADA on fighter B, so there's 3,000 for B, and then A wins. What would that mean? That means that, I mean, there's 5,000 in total, and those the two that put on A both get 2,500, so they put 1,000 in, get 2,500 out. So that means basically you get 2.5 times more than you put in. So basically these tokens that you got, if somewhere you have, wherever in the Oracle or I don't know, you have this information that one of these tokens is now worth 2.5 ADA, Loveless, then basically automatically you could have some where you put in these tokens, you burn these tokens, and in return you are allowed to take ADA away. And then it would be, I mean, everybody can collect their own winnings. That might also work actually. And then we
Yeah.
have the, yeah, sorry.
Yeah, Adrian, you want to say something?
No, go ahead.
So I'm thinking because I think I forgot the vulnerability that we have in the case that if we, for example, usually you have like a ratio like 3-to-1
Mhm.
of bets from A to B and stuff. So if we present the fighter, the Oracle presents who won with the ratio, and I consume as any subset that like within that subset of inputs creates the correct outputs. I can enforce that the winners get like the winnings, and that the money that the winners get comes from the losers. That's enforceable within the transaction, independent of the other amount of UTXOs. So I think that why wouldn't that work, for example?
I actually think, I mean, maybe I should rephrase my idea. I mean, it still has this problem that someone has to keep track of all bets, but I mean, your idea with the Oracle, for example, let's assume for the moment the Oracle does that, yeah?
Yeah.
So my idea would be you place a bet on A or B, and depending on whether it's on A or B, you get a token, like basically like a receipt for your bet. For each Loveless you place, you get one of these receipt tokens. And there are two different sorts. I mean, there's an A token and a B token for fighter A and fighter B. So let's say Karina and you each place 1,000 ADA on fighter A. Then each of you would get a billion, I mean, 1,000 ADA times a million Loveless, a billion of these A tokens. Let's say 3 other people place 1,000 ADA each on fighter B. So they each get one of those B tokens for every, I mean, a billion B tokens. Right. And if now the Oracle keeps track of these numbers, I mean, the 2,000 ADA for A, 3,000 for B, then once the fight is over, you know the ratio. You know, I mean, there are 5,000 ADA available in total and 2 winners. I mean, in this case, I mean, my example is simple because you and Karina bet 1,000 each. But I mean, if it's like different amounts, you can of course do the calculation as well. So in that case means, I mean, there's 5,000 in total, and you both bet the same amount on the winner. So each of you should get 2,500 ADA in total, right? In the end. I mean, there are 5,000 are in the pot. You and Karina won, so the pot gets split equally between the two of you. So each of you gets 2,500. And if now the Oracle knows that, it could just say, okay, token B is useless because B lost, and token A is now worth 2.5 Loveless. And then the smart contract would just say that for burning one of these A tokens, you can take out of any of the bets 2.5 Loveless. And then basically you can collect it from, you don't even have to combine it in one pot. I mean, you can take it from any of the bet UTXOs. I mean, you burn your tokens and you take your money out. And then in the end, because there are 2,000 or 2 billion, so it adds up exactly.
Yeah, I think that will work. I that will work. But what I'm not sure if we can avoid the minting by just putting who betted how much, and then having the ratio in the Oracle and the who won. You have the total amount is whatever amount adds up from the inputs. So the inputs in total like 5,000, and then there's 2 winners, so it's 2,000 to 500 for each. And if for some reason the inputs add up for if there's any difference between, because for example, if there's just one winner and that winner has to take like 2,000, but there's 10,000 ADAS input, the rest should go back sort of like a bet. Like we should like the change goes back to the original pool of UTXOs. Make sense? And the information lives in the datums.
Right.
I think what you explain is already like kind of in some way implemented for liquidity pools and stuff like that. Maybe a bit different.
Yes.
So
Sure.
I think that works. So it's very fast that works.
Yeah, exactly. It's a bit like a liquidity pool where you get these liquidity tokens when you put liquidity in, and the liquidity pool keep track of the ratio. Sorry.
Yeah, I mean that will work. But maybe there's a simpler solution that we cannot come up with right now.
Right.
Although like we use like almost all the time for Adrian's project, and we have 2 other projects. I'm not sure if we want to like what we want to do, like take a look at the other projects, keep going with this one.
Are there 2 more?
I mean, there were, I think we had another one about a marketplace, NFT marketplace, but I'm not sure if the person.
Pratipa is not here. I think she
Oh.
presented the other project in the past session, so but he's not here.
I see. So is anybody else here that also wants to present the project? Okay, in that case, the problem is not existent, I think.
Yeah. Anderson, you didn't do the Oracle?
Oh yeah, that's right. Anderson was the other one.
Not yet. I didn't manage to work on it, but I know I'll reach out to you later on to help me figure it out correctly.
Of course, yes, you can ask us.
Yes.
Right, but that means then we, in principle, I mean, we can continue with Adrian or we can stop, but there's no other person wanting to present anything today, right?
Yes, yes.
Okay. Okay, so yeah, I think the liquidity thing, like the sort of the liquidity pool thing will work, Adrian, if you want to implement it that way, and that will scale properly.
Okay. So I don't know if you can share something about that, some repository to look up at that and see if I can implement it.
I think I mean, are you aware of how Uniswap works on Ethereum?
The Unix, no, I am not aware.
That's like the most popular DEX, decentralized exchange on Ethereum. And on Cardano, some people have tried to build clones of it, basically. Actually, I think I'm not sure whether it still exists, but back in the days when Plutus was young, I wrote a Uniswap clone for Cardano, for Plutus. And that used to be in the Plutus examples in one of the Plutus repositories. I'm not sure whether that still exists. I mean, the idea on Uniswap is that people provide liquidity So if you want to swap two tokens, no idea, whatever, ADA against USDM or something, then there are these, I mean, first of all, on Ethereum. On Ethereum, so you have two tokens, whatever, Ether and I don't know what other popular token you have on Ethereum, USDC. So you have Ether and USDC, and then in one smart contract, that's the so-called liquidity pool, you put both tokens. And I mean, the way the exchange works, it's actually interesting. I mean, it's a nice idea. It's this constant product formula. I don't know. Do I have? I think that's nice anyway. To hang on. I mean, it's not directly related to betting, but I'm also not sure I can. Let me just. Oh, there's this whiteboard thing. Can you see? I am just creating this whiteboard now.
Not yet.
Okay,
No.
not. Okay, that's fine. That's a bit strange. I can only share it with like Karina, Antonio, and Robertino, so that's a bit silly. Let me think. I'm trying to think what the easiest way would be for me to share some graphics. Sorry.
I mean, you could use if you want, you could use ScaliDraw, and like
What's that?
it's the one that I use to give the lectures. Adrian shared something.
Yes, I have created a Jamboard. I think it
Ah.
could work.
Right. I sent you a request to.
Yeah, me too.
Yeah, me too.
Let me just.
Oh, it says I'll get an email. Okay, I must check my email then, I suppose.
I think everyone with the link can access now.
Okay. Let's try again then.
Yes, looks good. Thank you. Right. Does that work? Okay, I can see it, but so how do I actually draw anything? Hang on. View only request, or I must request edit access.
Oh, right. I think you can also edit it
Yeah,
now.
now I see it. Now I see the pen. Right. So actually I mean, this has nothing to do with bets per se, but so the idea is you have these smart contract. I mean, it's on Ethereum, but you can do something similar on Cardano. And the idea is it should be.
Sorry, I'm sorry. Could you share your screen so the recording gets the screen as well?
Oh yes, sure. Hang on, please.
Awesome.
Right.
Thank you.
Right. So I mean, it's actually quite ingenious. So let's say it's Ether against USDC. I have no idea I mean, it's probably a bad example because Ether is like crazy valuable. But let's say so initially somebody opens this so-called liquidity pool. So he has to put in tokens of both assets. So let me see, can I? Oh, yeah. Okay, so let's say he puts 1,000 USDC in, and I don't know, 1 Ether. Let's say 1 Ether. Right. And now the way it works, I mean, it's called an AMM pool, automatic market maker, or AMM DEX, automatic market maker DEX. So the interesting part is that price discovery is automatic. And the way it works is it's used as this so-called constant product formula. So you look what tokens are in there. So in this case, in the beginning, somebody put 1,000 USDC and 1 Ether in there. So the product is 1,000 times 1, which is 1,000, obviously. Right. And now the idea is people can take out one of the tokens and put another one in. I mean, you can swap. You can exchange USDC for Ether or the other way around. And the way it works is the smart contract enforces that this product of the two always stays the same. So if, for example, now I want to convert 10 USDC into Ether. So I put 10 in. So afterwards there will be 1,010. And the product has still, so I need to do a calculation now. So the products, so I want to, in the end, I have 1,010 USDC in. So now the question is, so X Ether and the product will be still 1,000. So in order to get X, I must divide 1,000 by 1,010. So afterwards, so to keep this constant product, I must have 0.99 on Ether in there. So that means I can take 1 out. So, I mean, 0.01. So can I somehow copy this whole thing, I wonder? Or do I have to draw it again?
With the, yeah, I don't know.
Anyway, let's just do this. So, so afterwards, 1,010 USDC are in there, and 0.99, sorry, 0.99 Ether, and the product I mean, 1,010 times 0.99 is not 1,000, but it's almost 1,000. Let's see. So that's okay. So it's a little bit too little. So I should have, let's say, okay, fine. So let's say that. What was it? 1,000. Right. Okay, so that means somebody can put 10 USDC in. So here I should also put the 1. So somebody can put 10 USDC in, and he can take 0.009 Ethereum out, Ether out, and this product is still 1,000. I mean, it's not. You get the idea, I hope. So that's how it works. And if you think about it, that automatically, I mean, normally of a price you expect that supply and demand. So if there's high demand, then the price increases. And that's also true here. So the first person that puts 10 USDC in gets 0.009 or so out. But if now the next person puts 10 in, he will get a little bit less of Ether out. So the more people swap in this one direction, the more expensive basically the Ether gets. That's just a consequence of this constant product formula. And so that's the idea. And of course, if you do it in the other direction, you can do it in both directions. So the idea is this product always stays constant. Okay, so that's the simple story. But now the more complicated story is, how do you incentivize people to actually put money in these pools to allow other people to swap? And that's where these liquidity tokens come in. So actually, when you put 1,000 USDC and 1 Ether in, you get a certain amount of so-called liquidity tokens. So the person that sets that up gets, I don't know, 1,000 liquidity tokens. And then if somebody adds tokens to the pool, he also gets liquidity tokens. And then the point is, okay, that's one thing. And then later burning the liquidity tokens again allows you to take out both tokens again. And then there is a modification to this constant product formula that it says it mustn't stay exactly constant. It must always increase. So with each swap that people do, a certain percentage must be added to this product. So that means the product over time gets bigger and bigger. So that means, I mean, roughly speaking, the amount of tokens in there gets bigger and bigger of both sorts eventually. So that's the incentive for these liquidity providers, because then, I mean, if let's say there are two, each put like half of what's in there in, and then after 100 swaps or so, the money has increased, and then if they both get their money out again, they all made a profit. Right, and the reason I'm telling you all of this is because, I mean, there's a parallel to what I was suggesting to, I mean, these liquidity tokens give you a right to take money out of this again, of these pools. And somehow this is similar to, if you think about it, to these fighters and the bets. So you can think of USDC as bets on fighter A and Ether bets on fighter B. And instead of like just one sort of liquidity token, in the case of Uniswap, you would get two sorts of liquidity tokens. I mean, for the fighter A part and for the fighter B part. And then in the end, using these liquidity tokens, you could put money out again. I mean, what I earlier said, I mean, this is Uniswap, but now if we have, can I, somehow all very strange, but anyway. No, can't I just write like normal text? Okay, what is this sticky? Okay. I mean, it seems I can only do like, but I mean, for text, I could, of course, also just do Notepad or something, right? And maybe that's the easiest, actually. Sorry, just bear with me. So, I mean, my idea was that, let's say we have Alice, Bob, Charlie, what was it, Daniel, and Eve. So Alice bets 1,000 ADA on fighter A. So Bob, let's say 500 ADA on A. Charlie, Daniel, and Eve, let's say 1,000 ADA each on B. So now my idea was that people get like betting tokens. So Alice receives 1,000 A tokens. Bob receives 500 A tokens. And Charlie, Daniel, and Eve receive 1,000 B tokens each. Okay, and then the fight happens. Fight happens. A wins. So the total pot is 1,000 plus 500 plus 1,000 plus 1,000 plus 1,000, which is 4,500. And basic, okay, and what was the right? And bets on A were 1,500. Right. So if I'm not mistaken, that would mean that now worth of an A token is 3 ADA and worth of a E token is 0. And that means that because Alice has 1,000 A tokens, she is allowed to take 3,000 out of this. And Bob received 500, so he can take 1,500 out. And Charlie, Daniel, Eve can't take anything out because their B tokens are worth nothing. So that was the idea. So basically, they get these tokens as a receipt, and then they can that entitles them to get their money. And we don't really care. So we don't have to combine the pots or anything. They can be completely separate UTXOs. In principle, we could have 5. I mean, we can leave these 5 UTXOs untouched. And then if Alice is entitled to collect 3,000 ADA by burning her 1000 A tokens, and it's up to her where she picks them. So, for example, she could take this, and this UTXO to collect her 1000, and then the smart contract would just make sure that, or actually, sorry, the validator could make sure that you can get some of the ADA out by burning an equivalent amount of A tokens. So this validator would check. You can take 1000 out, but only if you burn 333.333 A tokens. And all the other validators would check the same thing. And then it adds up. If A and B both do it, no matter where they, from which UTXOs they collect, in the end, basically everything would be neatly separated. And this would have the additional advantage that you can also trade these tokens in principle. Maybe after Alice placed the bet, she gets cold feet, and then she sells her A tokens to somebody, to Bob or to Anderson. There would be like a secondary market for it, which might also be nice. Or maybe she's too lazy to collect her winnings and she rather sells it to somebody else who has the patience to collect. And what Robertino was pointing out, it's somewhat similar, this idea, to this liquidity pool idea of Uniswap or AMM dexes, because you have these liquidity tokens, and in this case, it's whatever you call them. It's not liquidity, it's bets, like betting tokens or gambling tokens, as receipt for your bets, and then later they entitle you to collect from the pot. So the question, of course, is this step here, who does this calculation? So somebody must keep track of how much was bet, how many A tokens and B tokens in total there are. So that is, again, the same problem, that somehow we need this global state. But one option would, the simple one would be what Robertino said, that it could be that the Oracle reports that, the Oracle keeps track of all the things. Or we could have this 10 UTXO ideas that in order to place a bet, you pick one of these 10 UTXOs, you get your receipts, you put your ADA in, you get your receipts, and the UTXOs keep track of how much was minted for A and for B. And then you need this one step that actually does this calculation here.
Once the worth of the token depends on the winning, on who won, and the amount of bets prior to the fight. So we don't have that constraint of like keeping up to date the price that other, like, the liquidity providers need have to have, like, so we can, like, so the Oracle just needs to provide it once and then everybody can read it.
Yes. Right.
So there's actually, with this design that you just provided, there's no issues of scalability, I think.
No, if you trust the Oracle, then not.
The Oracle, whatever system the Oracle has to provide the winning can be used to query all the UTXOs and provide the ratio.
If you have to trust the Oracle anyway to tell you who won the fight, then you probably can also trust it to tell you how many bets were placed, I suppose.
Yeah.
Yeah, that's true. And the Oracle could,
sorry, like, the Oracle doesn't need, like we talked in a prior lesson, I don't remember which one. The Oracle doesn't need to be like a specific entity. It can be like a small, like, blockchain-ish structure where plenty of entities provide their own, and there's an algorithm that decides what's the actual value and all that. So it doesn't need to be a centralized thing like the one we provided or Adrian used in this case.
Yes, the idea is that several people can participate and somehow basically vote on the Oracle and so on. That's right. Yes. Yeah, just ideas. Maybe that would make it easier if you have these A and B tokens in your case. Not sure. But then the nice thing is then you don't need to, I mean, you don't need to keep track of the people. I mean, you don't need a list of, I mean, you don't have to remember that Alice bet 1,000 and Bob bet 500 and Charlie and Daniel and Eve. I mean, all you have to keep track of is the total. So I mean, the state is like constant space. You only have to keep track how many bets were placed on A and on B, but you do not have to keep track of who did those things. So that's an advantage of this, I think. You don't have to remember, I mean, you don't have to keep track on the blockchain who wins how much. All you have to keep track of, and so maybe also the distribution is easier because you just keep two running totals basically of A and B, I mean, or the Oracle does or whatever. And then in the end, you just divide like what I did here, the 4,500 by the 1,500.
And another advantage by using this system is that if you have a bunch of small bets for A and a huge bet for B, it could be possible that you run out of space before reaching all the inputs necessary to pay for this huge transaction. So you can just collect half of the tokens and then create another transaction with the other half of the tokens.
Right, that's also an advantage. You don't have to collect all of that at once. Exactly. So you could see how many fit, how many inputs you, maybe 10 or so, and then you collect your earnings in several transactions. Exactly, that's another advantage.
Okay, Andrea, so let us know when we can invest. And
So I bet on Robertino. He will win the fight.
I don't know.
Don't worry, it's just a joke.
Okay. But I think that's a really good and beautiful solution. I think I've never have reached that solution by myself.
Yeah, just a matter of experience. Okay, yeah, but I don't know whether there actually is. I think I asked it last time already, but I forgot. Does anybody know? Is there something like that already on Cardano, like a betting platform, decentralized betting?
Didn't check.
Maybe not.
Hopefully.
I just know when
yeah.
I just know when we were in Nairobi, that was about lotteries. I mean, it's not the same, of course, but still. So there's certainly interest in these things.
Yeah.
I
I think the issue is like the Oracle side. So maybe Adrian can talk with the OrcFax or Charlie 3 oracles to see. I mean, I believe Charlie 3 only provides token ratios, so that wouldn't work. But maybe you could become a part of the OrcFX network, and you yourself be one of the oracles, and I don't know. Or create your own Oracle system, which that by itself is already a huge task.
I'm not sure. I'm also bad with names, but I mean, there's this new stablecoin that we talked about some time ago, USDM. That's not algorithmic like the one you presented, Robertino, but like fiat-based, backed fiat-backed stablecoin. So where people actually deposit US dollar in a specific bank account, and then for each deposit you can mint the token. And they are working with some Oracle. So and I thought that was Charlie 3, but I'm not sure. So in that case, the Oracle like checks a bank account, a real world bank account. And so basically the Oracle certifies that certain deposits have been made to that account. So somehow they managed to like hook up the Oracle with some banking system. So what I'm trying to say is it's not just exchange rate. So there are oracles for other things. So it probably should be possible to also have like fights or results of fights or something. Maybe then it must be hooked up. I don't really care about sports that much, but surely there are like news tickers that you could, I don't know, Reuters or whatever, that then this Oracle could be connected to, and then once it receives the message about the outcome of the fight, it could somehow certify that. I'm not sure how actually it would work in practice. Or whether the owner of the Oracle just has to watch the fight on TV and then manually do it. Or maybe one could also link up with, like, I mean, there are also obviously non-blockchain based betting systems. So maybe they also have like their feeds. Probably there are standardized feeds for all sorts of sports events. Not sure.
Yeah, I'm sure there is. So
Yeah.
Maybe you could take 3 different fees: one from US, one from Europe, one from China, and then like take the mean or whatever.
Yes. Yeah. I also agree with you, Robert. And probably the biggest problem with actually doing this is the Oracle, to get a reliable Oracle. But apart from that, I think it's certainly doable on the blockchain. Okay, I think our time is up, and there was nobody else who wanted to present. So I think that's then it with this course. Did we say anything about certificates? Robertino, did we want to issue certificates for participation or something?
I think we talk about it, Anderson. I'm not sure because I think ABC issues them.
Yeah.
Right.
Yeah, we can
Okay.
we'll issue them. So we'll align on that probably by next week. And then
Okay.
we can have like a short ceremony. So I don't know, to be a hybrid event so that we can have those who are not able to be here physically and those who be here physically. So I'll communicate on that by next week.
Okay, great. Okay,
Yes.
then if there's any open ends, then we can still discuss that.
Yes.
Okay, perfect.
Awesome.
Then I think that's it. Are there any remaining questions or remarks?
None on my end.
Okay, then thank you all of the 2 of you for participating. No, I mean today it's just give me a second. Somebody at the door. Just a second. Okay. Yeah. Thank you very much. I hope you learned something. And yeah, then we probably meet one more time at this ceremony. Okay.
Yes.
And in the meantime, if there are any questions or so, I mean, you can still contact us on Telegram, for example. Okay. Yeah. Then thank you very much, and take care. Have a nice weekend. And then we'll probably talk again in a week or so for this ceremony.
Thank you. Thank you,
Thank you very much. Thanks,
Thank
everyone.
you.
Bye.
Bye bye.
Thank you.